So this is the last video for 8.1, and I actually forgot, we were doing the histograms in the last example, and I forgot there was a part to the last one, so I'm going to just pick it up in this video. So remember, at the end of the last one, we did this example where we have a bag that had 4 red, 3 blues, 2 greens. We picked 5, right? We figured out all the outcomes where I got 2 blues, right? Blues are what I'm counting. And so I can have it with 3 blues, 2 blues, 1 blue, or no blues. And we drew the histogram and did all that, and then I forgot, I ended the video there, and I forgot there's a part B. Alright, part B is asking you, using the new notation, find the probability that my random variable x is greater than or equal to 2, right? My number of blues is greater than or equal to 2. And so this would be, I get the number of blues in my handful is greater than, or, because that's the equal to 2. Which would be, there's 2 outcomes, right? I get 2 blues or 3 blues, right? So this would be the outcomes where I get the probability x equals 2, or probability x equals 3, right? The or. And so it's just these 2 outcomes. So you add those together, because they're mutually exclusive, because they're set up, right? I either have 2 handfuls or 3, right? There's no overlap, because they're separate. And so I add those 2 outcomes up. So the probability that I get 2 or more blues in my handful is 15 out of 126 plus 60 out of 126, which comes out to 75 out of 126, right? 75 out of 126, which is, if I write that as a decimal, 0.595. Alright, so that's the probability that I get a handful that is greater than or equal to 2, which, and again, that means that's the chance of getting 2 or more blue handfuls. That's another way to write it. I get 2 or more blues in my handfuls. About almost a 60% chance, 59.5. Alright, so the last one, we're not going to draw any more histograms, although you could. Alright, the last one are just looking at probability distributions and actually doing more of these cases, so this actually kind of goes more with what we're doing today anyway. Or doing on this video, not today, this particular video. Alright, so I've got a survey. Alright, so a lot of times we can do a survey, we can put it in a frequency table, right? We can tally how people answered questions in a survey. And so this particular survey was given to 120 unemployed people. Each person was asked how many years of high school he or she completed. The random X assigns the number of years of high school, so again, it's numbers, right? They complete no years of high school, 1 year, 2 year, 3 years, or all 4 years. And then these are the answer. Frequency would be how many people did that. That's the number of people, right? And so I'm just going to do the probability distribution in this case. And I'm going to draw it sideways just because it's a little easier to do sideways. And so my random variable x represents my number, right? That's my number of years of high school. Probability, right, that I have so many is going to come out of the number of years, number of people out of my total, right? Part divided by total. And so 0, 1, 2, 3, 4 are the number of years. Those are my x values. So if I draw my histogram, 0 to 4. The probability that they were didn't complete any high school was 6 of them out of 120. 1 year of high school was 24 out of 120. 2 years of high school, 39 out of 120. 3 years of high school, 30 out of 120. And 4 years of high school, 21 out of 120. It should be all the people. If I were to add those up, it should be 120 out of 120. Alright, so relative frequency tables, probabilities are simple. They're like relative frequency tables. It makes life a lot easier when we have them. I don't have to do any counting methods. Don't have to draw a sample space out. Alright, I've got them. And so we're just kind of practicing some new notation. So this is sort of the new notation. Alright, so instead of saying probability that 3 people, or not 3 people, probability they completed 3 years of high school, we write probability random variable as x. That means 3 years, so we're going to interpret it. 3 years of high school. Well, that probability is this probability. That was 30 out of 120, and then I'm going to write it as the decimal, which is 1/4, 0.25. And then explain what it means. All right, this is a new notation. We're going to kind of explain what it means. And so the probability is 0.25, and so we usually talk about probabilities in terms of percents. So 25% of those in the survey completed 3 years of high school. Right, that's what it means. Right, there's probability of 0.25, 25%. The new part's the sort of using the math notation. So same thing here. Probability x is less than 3. Well, less than 3 means probability x's, well, less than 3, 0, 1, or 2, right? Those are the cases that are less than 3, and so I add up those cases. Probability of my random variable x is less than 3 would be 6 out of 120, that's the 0 case, 24 out of 120, that's the 1 case, and 29 out of 120, that's the third case. And I'm just going to type that in my calculator and find the decimal approximation. Comes out to be 0.575. Alright, now what does that mean, right? Because again, this is sort of the new symbol, x less than 3. Right, but what does it mean in terms of my application? Right, well, it means, I'm going to write it again, that the probability is 57.5, or 0.575. But usually when we talk about probabilities, we do it in terms of percents. So 57.5% of those in the survey, of the unemployed people in the survey, completed less than, right, that's the less than symbol, 3 years of high school. Right, that's what that symbol means. They completed 1, 2, or not 3, not including it, 3, less than 3 years of high school, no equal to. Alright, and so that's what it means. Alright, the last example, a lot of times in statistical data, they'll give you a range of values, because there would be infinitely many ways that you can give out a salary, because, you know, you get all the kind of decimals if you wanted to go out to the, you know, the penny or beyond. And so what they do instead is they give you a range. And sometimes if you look at data given in statistics and math books and things like that, sometimes this is how they do it. All right, so I always kind of wanted to get you used to these sort of special cases where they give you a range of values. Whenever they give you a range of values, what you have to do is, well, you have to base it on what's the middle value. All right, we assume the middle value, the midpoint, is the average of the interval. Right, and so that's what we use. So we have income brackets for employees. We have income brackets between 15, and we'll go to the little asterisk in a second. Because again, a lot of times books will do this. A lot of times if you're reading a journal or something and give you statistical information, they'll do this and they'll put an asterisk and you have to read it at the bottom of the page. What does that asterisk mean? Well, that asterisk means, if I go down here as the asterisk, it means the income bracket between $15,000 and $24.99 includes salaries from $15,000 up to, but not including, $25,000. It means I can have all of the decimals, so I can have 24,999.999999999. As many nines if we want after my decimal as we want. And so what it really means is this is our range. Alright, my x values in my first bracket, and this is true for all of them, they just give you the example in the first bracket, is I can have a salary between $1,500 and $2,500, including the 15 where I start, but not including the 25. But I can go up to as close to the 25,000 as I want. And so when I compute the midpoint, I keep that in mind. I use the 1,500 as the low end of my bracket, and I use 15,000 as the low end, and 25,000 as the high end. And again, same thing can be said for the other one. So you always use up to the next bracket. So when I go to find my midpoints, which is what my x value assigns each employee the midpoint of his or her bracket, because they didn't give us the exact salaries, I'm going to construct a probability distribution, and then I'm going to use it to solve that probability. All right, so first, though, the midpoints. So x equals the midpoint of the income bracket. I can read that. And so, again, I'm going to go sideways. I'm going to go down here so I get a little more room, because the brackets are actually going to be fairly numbers are going to be fairly large. I need a little more room to work. And so the first one, again, using that first one, the midpoint, well, this first bracket really goes up to 25,000. You look here, right? That's what remember that asterisk was telling me. And so to find the midpoint of the first bracket, it's the average between my high and my low. So I take my 15,000 plus my 25,000, right, the high or low values, and divide by 2, right, which is going to come out 40,000 divided by 2, which is 20,000. And that should make sense. Just looking at it, you can see the halfway point between 25,000 and 15,000 is 20,000. So that's my first x value, 20,000. Right, the next one will be found the same way. Alright, next one, as I look between 25,000 and 35, right? My next bracket starts at 25 and ends up to the next one, 35. So 25,000, 35,000, right, which is 60,000 divided by 2, so that comes out 30,000. So it goes by 10, so the next one is 30,000. The next bracket, all right, which would be 35,000 up to 45. Right, the halfway point between 35,000 and 45,000 is 40,000. So that's the next one. Make sure I got all my zeros. All right, the next bracket would be between 45,000 and 55,000, right, which would be 50,000. And then the next bracket would go between 55, right, 55,000 up to 65,000. So 60,000. I would be able to squeeze my last one in, and there's one more, right? There's the one more. There's the 65,000 up to, remember, this goes really up to 75,000. So 70,000 is in the middle of that. All right, so midpoints in our brackets. All right, so whenever we're given an interval of data, we always have to use the midpoint. We always have to kind of keep this in mind. Right? It's the value between my very lowest possible up to the highest possible, which again is the next value, next bracket size. And so there are my midpoints. 20,000, 30,000, 40,000, 50,000, 60,000, 70,000. All right, then we assume, so it is based on an average, so it is a pretty, again, so this is just an estimation. This is really just an estimated probability. Because the 25 people might not have 20,000, but we're saying the average of them is going to be that middle, that 20,000. All right, so 25 people land at the 20,000 bracket, and so I need to know how many employees I have. So they didn't tell me. All right, so number of employees, my n value. So I have to add up all of those. So 25 plus 80 plus 95 plus 35 plus 10 plus 15, plus 5, not 15. 250. All right, there are 250 employees. All right, total number of employees. They didn't tell me anywhere, so I had to figure that out. All right, so let's just add up all my employees. So total of 250 employees, which means probability of somebody having a salary in the first bracket, which we average out to $20,000 as their salary, is 25 out of 250. And I'm just going to leave it 25 out of 250. 30,000, well, 80 people land in that bracket. 85 out of 250. 40,000, 95 out of 250. 50,000, 35 out of 250. 60,000, 10 out of 250, and 70,000, 5 out of 250. And to double check myself, you can always add them up, make sure it adds up to 250 out of 250. And this should add up to 250 out of 250. Alright, so there's my probabilities using midpoints. So whenever it's a bracket case, you always do the midpoints this way. Alright, that's the hard part. Once I've got that, now the question. So answering the question, find the probability that a random variable x is less than 45. So find the probability that a person in this company has an income of less than 40,000. So probability they have less than 40,000. Oh, sorry, 45,000. Well, that would be all of these. These are all of the guys that land in the category of the less. All right, 40,000 is less than 45. That's less. And see, add up those three outcomes. 25 out of 250, plus 80 out of 250, plus 95 out of 250. Which again, I'm just going to type all of those out in my calculator and go. And so it comes out to be 200 to 250, which is 0.8. Most of the people, right? 80% of the people have a salary less than $45,000 at this particular company. All right, so that's a bracket example. All right, so we'll stop there. All right, so make sure you look at this. This last case, again, shows up once in a while, and make sure you understand if you're given an interval, you have to do midpoints. And you have to do them like this.